Welcome back. So, for this part of the literature review, we're going to tackle a really core question in second language learning. How does what we hear connect to what we say? We're exploring the fundamental link between perception and production.
Yep, we're just going to pick up right where we left off and dive straight into the theories that really are the foundation for this whole study. So let's jump right in.
Okay, let's get right to the heart of it. The main idea here is actually pretty simple, but it's incredibly powerful. It's this: how our brain hears and sorts sounds, well, that directly shapes how we actually produce them when we speak. To put it simply, perception is the boss of production. So you might be asking, why is this link so foundational? Well, it's because it's pretty much the starting point for understanding, well, everything. Every challenge, every success that someone has when learning to speak a new language. You have to be able to hear a sound correctly before you can ever hope to say it correctly. I love this analogy. Think of perception as the architect of your entire sound system. When you're learning a new language, your brain is just constantly listening, right? And that whole process of listening is what's building and organizing this huge mental map of sounds. That's your phonetic and phonological system. And of course, that mental map, that becomes the blueprint for how you speak. Once your brain has put a sound into a specific category, that's what tells your mouth how to try and make that sound. So the way you speak is literally a direct result of the way you hear. Okay, so if perception is the blueprint, that leads to a really important question, right? How can we actually predict the specific challenges a learner is going to face? Well, one of the biggest and most influential answers to that comes from Flesch's speech learning model, and it builds directly on this perception production link we've been talking about. So Flesch's speech learning model, you'll see it called the SLM, it gives us this amazing predictive framework. Basically, it argues that a learner's ability to tell the difference between new sounds in a second language, it all depends on how phonetically similar those new sounds are to the sounds they already know from their native language, their L1. Okay, this slide is super interesting because it just lays out the core prediction of the SLM so clearly. On the one hand, you have sounds that are really similar between your first and second language. Now, you'd think that would be easy, right? But it's actually the opposite. It's harder to notice the tiny differences. Your brain just kind of goes, close enough, and lumps it in with what it already knows. But then, on the other hand, if a sound is totally different and new, well, that one stands out like a sore thumb, making it way easier to tell apart. And here's the real kicker from Fledge's model, the big takeaway. It connects everything we've been talking about. The model predicts that if you can train someone to get better at just hearing the difference between these sounds, that improvement in perception will, over time, lead to better, more accurate production. So, in a nutshell, better hearing leads to better speaking. It's that direct. So the SLM is all about that raw phonetic distance, but it's not the only game in town. There's another really influential model from Best and Tyler called the Perceptual Assimilation Model, or PAML2, and it comes at the problem from a slightly different, more cognitive angle. It's all about this idea of mapping. So what do we mean by mapping? Well, the PAML2 model suggests that when you hear a new sound in a second language, you don't hear it in isolation. Your brain instinctively tries to fit it into the sound categories you already have from your native language. You're trying to assimilate it, to make it make sense within the system you already know. Let's walk through that process. It's kind of like a three-step thing going on in your head. Step 1, you hear a new sound from that second language. Step 2, your brain instantly tries to filter it through your existing native language sound categories. And then step 3, depending on how it gets mapped, where it fits in, the model can predict how easy or difficult it's going to be for you to tell that sound apart from others. And this table here lays out the different ways that can play out. For instance, look at the top row. If you have two different L2 sounds, but your brain maps both of them onto the same L1 category you already know, well, you're going to have a really tough time telling them apart. But if those two new sounds map onto two separate L1 categories, it's way less challenging. And the model even has a place for those weird sounds that are so new, they don't really map onto any existing category. Okay, so let's just take a breath and compare these two for a second. Both models are trying to solve the same problem, right? They both want to predict how we perceive new sounds, but they get there in different ways. The SLM is all about the pure physics of it, the acoustic phonetic distance between sounds. The PAM-L2, though, it's more about the mental filing system, that cognitive process of how we map new sounds into our old categories. All right, so we've got these two really powerful models. But why does any of this matter for the study we're looking at? let's connect these theories back to the actual research he's doing. Well, here's the justification. These models are basically the entire reason for this study. They establish that perception isn't just important, it's central to learning to speak a second language. And they give us that solid theoretical link between hearing and speaking. So this gives the author a solid framework to really dig into L2 French vowels. He's using these theories to investigate exactly how learners categorize those vowel sounds and then how that mental sorting process affects how they actually pronounce them.